In this video, we're going to take a look at standard A.8A, which says the student is expected to solve quadratic equations having real solutions by factoring, taking square roots, completing the square, and applying the quadratic formula. Let's take a moment to consider these different methods that can be used for solving quadratics. For factoring, that method is applicable with quadratic equations that when set equal to 0 can be factored. The square root method is applicable with quadratic equations that do not contain the linear term bx. An example of that is x squared equals 200. For completing the square and the quadratic formula, both of those methods are applicable with all types of quadratic equations. So quadratics may have one real solution, two real solutions, or no real solution. Let's take a moment to look at the solutions graphically. So for one real solution, that means that the quadratic equation touches the x-axis in one spot, as shown right here. For a quadratic that has two real solutions, the quadratic equation crosses the x-axis at two different spots, and those two spots are our solutions. For a quadratic that has no real solution, the quadratic equation does not touch or cross the x-axis at all. Let's look at a problem that comes from the 2016 Algebra 1 STAR test for this standard. The problem says, the sum of the first n consecutive even numbers can be found using s equals n squared plus n, where n is greater than or equal to 2. What is the value of n when the sum is 156? So we are given the equation s equals n squared plus n in the problem. And they also tell us that the sum is 156. So we're going to substitute in 156 for the variable s. Now I'm going to rewrite this equation as n squared plus n equals 156. To solve a quadratic equation, we have to set the equation equal to 0. So we're going to subtract 156 from both sides of the equation, and we'll get n squared plus n minus 156 equals 0. So the method that we're going to look at first, or attempt, is factoring. So when we factor, a strategy for students is to make a factor table. I have actually done that already here. So the first column of the factor lists the factors of negative 156, and the second column is the sum of the factors of negative 156. So for example, in this first row, 1 times negative 156 does give us a product of negative 156. When I add those two factors, they give us a sum of negative 155. So what we're looking for is a set of factors that multiply to give us negative 156 and add to give us a 1, because that is the coefficient in front of this second term. So if we look through the factor table, we will see that the factors negative 12 times 13 give us the product of negative 156, and when I add those two factors, they give us a sum of 1. So this is the set of factors we need. This means that we can factor this trinomial into n plus 13 and n minus 12 equals 0. Now, because of the zero product property, which states that if we multiply two values, or the product of two values, if that product is 0, then at least one of those factors has to be 0, if not both. So because of that property, we're going to set each of these factors equal to 0. And we're going to solve each equation for n. So subtract 13 from both sides, and we get n equals negative 13. For the second equation, we add 12 to both sides, and we get n equals 12. So two different answers here, are they both the answers that we need? Well, if we go back to the problem, it says that n has to be greater than or equal to 2. So negative 13 is not greater than or equal to 2. So we're going to disregard that answer. So the answer for this problem is that n equals 12.